So we're going to learn travel salesperson problem using branch and bound. So this is the example that is given in the textbook. So the graph will be given to you, and based on the graph, you have to draw the create a cost matrix, adjacency matrix over here. So now, what is the first step to solve travel salesperson problem using branch and bound? So once you create the matrix as such, first step that you have to do is reduction method. You have to apply reduction method on this matrix. So first let us reduce a row and then we will reduce a column. So how are we going to reduce a row and reduce a column? So in this, when you look at this row, each and every row will have a minimum weight. So in the first row, the minimum weight is 10. So what you're going to do is take 10 outside. When you take 10 outside, subtract 10 from each and every weight in that particular row. So now here it's infinity. Ignore. 20 minus 10 is 10. So it's 10 here. 30 minus 10 is 20. 10 minus 10, 0. 11 minus 10, 1. So you take 10 out and you're going to reduce a row. Next row, which is minimum in this? 2 is the minimum weight. So what you're going to do, you're going to reduce 2 from each and every weight. So here 2 minus 15, it's 30. Then you'll get infinity. 16 minus 2, you'll get 14. 4 minus 2, you're going to get 2 and 0. Next, the minimum cost is 2. Take 2 out and reduce it. Next minimum cost is 3. Take 3 out, reduce it by minusing it. Next, the minimum cost is 4. So take 4 out and minus. So this is row reduction method. You've reduced a row, taking all the minimum weight outside, and then you're subtracting with each and every weight. Next, so this is the first step. And then what you have to do is, you have to add the entire minimum weight which is taken out from each and every row and add it. You will get 21. So 10 plus 2 plus 2 plus 3 plus 4, you will get 21. Next, let us reduce column. So we are going to work on this matrix itself, which is already reduced. Now you are going to reduce column wise. So column wise, when you look at this in this matrix, which is having minimum weight 1, take 1 outside and minus 1 from each and every weight within this column. So it will be 12, 0, 15 and 12 minus 1 is 11. Now next here, the minimum weight is 0. Take 0 out. You minus, it's as such. Next, the minimum cost is 3. You take 3 out in this. 3. Take 3 out and minus. So this is going to be 17. It will be 11, infinity, 12 and 0. Here the minimum cost is 0. Here it is 0. And then now you have reduced column wise and add. So 1 plus 3, it is 4. So now you got two numbers. When you reduce a row, you're getting 21. And when you reduce a column, you're getting 4. So now total cost of reduction is 25. How did we get 21 plus 4? So now you got the reduced cost as 25. So you have to know what is reduced cost. So the reduced cost is 25. So we are going to assume that the minimum cost of the tour may be 25, or it can be more than 25. So now next step, what you're going to learn is, we are going to learn how to use state space tree using branch and bound and find cost of each and every node using the ranking function. So let's start with node 1. So first you have to know the cost of 1. So this 25, the reduction method that you apply row wise and column wise, that method, and you get the cost 25, this cost will be applied to 1. Next, now you're going to generate the space tree, right? So here how many vertex do you have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 vertex. So from 1 you can go to 2, to 3, to 4, to 5. Now you have to find the cost of 2, 1 to 2, 1 to 3, 1 to 4, 1 to 5. So let's start with 1 to 2, which means vertex 1 to 2. How are you going to find that? So now there are a few steps that you have to follow. The first step is to find the cost of 2. Okay, the steps to find the cost of 2, which is from 1 to 2. So you are going to give the first row, that means the first row will be infinity. You're going to set all the first row as infinity. So you're going to use a reduction method, not the main matrix. You have to use a reduced matrix to solve this or to find the cost of 2, 3, 4 and 5. So you just leave the main matrix apart and now you just work on the reduced matrix, which you got 25. Okay, so now, first step is what? To find the cost of 2. First step is the first rows will be infinity and the second column is going to be infinity. Plus, that's the second step. So first row infinity, second column infinity. Then what are you going to do? From 2 to 1. Okay, 2 to 1. Second row 2 to 1, right? That would be infinity. Cost of 2 to 1 is going to be infinity. And then what are you going to do? You write the other weights as such. That is 0, it is 15, 11, and here it is. So this is infinity, ignore it. This is 11, infinity, 12, 0, 0, 2, 0, 0, sorry, so you have to ignore 0 here. Okay, 2, 0, infinity, 12, 0, 2, 0, infinity. So you've got this. Next step is, what do you have to do with the next step? The next step that you're going to do is, again you're going to reduce row wise and column wise. See, is there any? Here it is 0, here 0, 0, 0. Column wise you're going to reduce 0, nothing, 0, 0, 0. And the total reduction cost is equal to 0. Now, next step is, so you reduce a matrix. So first step is, the first row will be infinity, second column will be infinity, 2, 1, 2, from 2 to 1, the cost is going to be infinity, and then reduce a matrix. Reduce a matrix and get the cost reduction, the cost. Now again there's one more step. You have to find the cost of this, cost of 1 to 2 plus our previous cost, parent cost, plus the cost that you got now. So what is cost of 1 to 2? Refer this matrix, the reduced matrix, don't refer this. 1 to 2, the cost is 10 plus the parent's cost is 25. Now you got this cost, right? This is our cap, which is 0. So total is 35. So the cost of second node is 35. As such, next step is we have to find the cost from 1 to 3. The same technique you're going to follow, the same technique. The distance is from 1 to 3, right? So first rows are going to be infinity. Okay, first row infinity, and third column going to be infinity. Then 3, 1, 3, 1. So anyways, you're not going to go back, right? So 3, 1. So this is 1, 2, 3, 4, 5. 3, 1 is going to be infinity. And copy the other numbers. So from 2, 12, infinity, 2, 0. Here 3, 1 is 0. Sorry, infinity. 3, 0, 2. This is 15, 3, infinity, 0. And here 11, 0, 0, infinity. Sorry, this is 12. Okay. Now, once this is done, these are all infinity. It's not 2, it's infinity. Now, once you got the array, next step is you have to reduce the matrix. So, check whether every rows are having, except this, every rows are having 0. So, this is 0, 0, 0, 0. Okay. Row wise reduce. Here do you have a 0? No. So, find which is minimum here. 11 is minimum. Take 11 out and minus. So, this you will get your 1, and this is going to be 4, and this will be 0. Okay. Now here there is 0, nothing, 0, 0. So now the cost reduced for this matrix, the reduced cost is 11. Now there's one more step to find the cost of 3. What is the equation? C of 1, 3 plus parent node's cost plus the cost of this 1 to 3 for this matrix. So what is cost of 1 to 3? Cost of 1 to 3 should be referred from the main reduced matrix. So 1 to 3 is 17 plus previous node value is 25, and now you got 11. So it will be 53. So the cost of node 3 is 53. So like this, we are going to find cost from 1 to 4, 1 to 5. So I am going to just show you the matrix. Maybe you can work at home how to follow the same procedure and find the cost of 4 and 5 as such. This is the other two matrix to find the cost of node 4 and node 5, referring to the reduced matrix. Next, I hope you got you can work the same way how you worked for 1 to 2, 1 to 3. Same technique you've used here. So here there is no reduced cost. That's what R dash is equal to 0. Whereas here you've reduced and you got 5 as reduced cost, and then when you add you'll get 31. So you got the cost for 2, 3, 4 and 5. Okay. So we have found the cost for 2, 3, 4 and 5. Now what is next? Next we have to explore to the next level. So now if suppose you are going to explore 2 and then go to 3, then to 4, then to 5 and find all possible nodes and then finding its costs and then going to the next level. If you're going as such, then this is known as FIFO branch and bound technique. So if you're going downwards, the next one is 6th node and finding its cost, then 7, then you're going and you're trying to expand and to find the minimum cost of each and every node. So possible is 6, 7, 8, that is from 1 to 2. Then this is for 2. So you can from 1 to 2 you can go to 3, 4 and 5. Then from 1 to 3 you can try with 2, 4 and 5. Then 1 to 4 you can try with 2, 3 and 5. So all possible path you can try and then keep on expanding breadth wise. If you're going ahead with this kind of exploration, then that is known as FIFO branch and bound state space tree. Now we are focusing on least cost branch and bound. So you have found the cost for each and every node here using reduction technique. So let us see in this different nodes which one is having the minimum cost. Node number 4, which is 25, is having minimum cost. So now next, so cost for you to reach from 1 to 4 is the cost is 25. Now let's expand the other nodes. So if it is 1 to 4, from 4 you can go to 2, then you can go to 3, then you can go to 5. So let's name the node as 6, 7 and 8. So from 1 to 4, 4 to 2, then you can try 1 to 4, 4 to 3, then you can go to 1 to 4, 4 to 5. So now what is the next step? You have to find cost for 6, 7 and 8. So you have to find cost for 6, 7 and 8. Now how are we going to do that? Now to find the cost of 6, you have to refer to the reduced matrix of 4. So 6 parent is 4. So this is a reduced matrix. You can refer to your previous session and get the matrix for 4. So this is a node, the reduced matrix for 4, and you have to use this matrix to find the cost of 6. Okay, so now to find the cost of 6, 7 and 8, you are going to refer the matrix, the reduced matrix of 4. So let's see how to find the cost of, right? What is distance from 4 to 2? Got it? So let's see how are we going to do that. So first step is, fourth row will be infinity and second column would be infinity. And also this is 2, right? So 2 to 1 going to be infinity. So let us refer to this matrix, and the reduced matrix that you have to refer should be a fourth node matrix. Okay, so now let's see, this is a matrix for fourth node matrix, referring to the reduced matrix for 4. What are we going to do? That means, so this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 here. Fourth row are going to be infinity. Okay, second column are going to be infinity, and 2, 1 are going to be infinity. 2, 1. Then copy the balance, whatever is there, you just copy it over here. So the first row is infinity there, second row is this, then third row is this, and the fifth row is this. So you got it as such. Now next step is what? You have to reduce it. How will you reduce? Row wise. Is there a 0? Yes. There is a 0. There's a 0 here. And column wise, there's a 0, 0, 0. So our cap is equal to 0. Now next step is what? What do you have to do? You have to find the cost of 6. So how are you going to do that? So how will you find the cost of 6? So cost of 6, right, which is 4 to 2. Cost of 6 is distance from 4 to 2. So 4 to 2 plus the previous nodes, that is the 6 nodes parent is 4, reduced cost, and now what is your reduced cost? So referring to the reduced matrix of 4 to 2, the value is 3. And here the cost of node 4 is 25. Plus, do you have reduction cost? No, it is 0. So total is 28. So cost for this node is 28. As such, we are going to the next level, that is cost from 4 to 3. 4 to 3. That means you have to find cost of node 7. So we are going ahead with the same procedure. We are going to use fourth node's reduced matrix. How are we going to do? It is 4 to 3, right? So now fourth row is going to be infinity and third column is going to be infinity plus 3 to 1. You're not going to go back to 1 from 3. So that is also going to be infinity. So you're going to follow the same step here. Same step, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Fourth row, infinity. Third column, infinity. 3, 1, infinity. And whatever is pending, we are going to just copy it over here. 12, infinity. Infinity, 0. This is 3, infinity 2. And this is 11, 0. Infinity, infinity. Next step, what do you have to do? Check whether this matrix is reduced or not. Here it is 0. This is not reduced. You are going to take 2 out. So this is going to be 0 here, and this is going to be 1. Nothing, it's 0 here. Now column wise, if you look at here, it's not reduced. So you're going to take 11 out, and this is going to be 0, and this is going to be 1. So here there is 0. Okay, now R dash is equal to 11 plus 2, which is 13. Okay, now we have to find the cost of 7. Okay, so 4 to 3 is 12 plus 25 plus 13. So you get 50. Next, we have to find cost of 8, which is distance from 5 to 4. So what do you have to do? 4th row infinity, 5th column infinity, and then 5 to 1 will be infinity. Same way, you're going to create a matrix 1, 2, 3, 4, 5, 4th row infinity, 5th column infinity, and then 5, 1 infinity, and copy the other numbers over here. So this is infinity, this is 12 infinity, 11 infinity, 0, 3 infinity, infinity, and this is 0, 0 infinity. Now check whether this is reduced or not. Now this is not reduced, so you take 11 out. So this is going to be 1, this is going to be 0. Here it's reduced. Now column wise, it's all reduced. So our cap is equal to 11. Now let's see the cost for node 8, which is a distance from 4 to 5, plus 25 plus 11. So 4 to 5. What is 4 to 5 here? It is 0 plus 25 plus 11, which is equal to 36. Now you got this as 50. This is 36. Now what is your next step? What do you have to do? You have to explore to the next level. So to go ahead with the next level, you have to see which one is having the least cost. So which one for sure it is? 6. So you have to expand further or explore 6. So now if it is 1 to 4 and 4 to 2, from 2 you can go to 3 or either 5. So let us number the node as 9 and 10. So now what is next? You have to find the cost of 9 and 10. For this, you have to get the reduced matrix of 6. So we are going to use the reduced matrix for 6, and using this matrix, you are going to work, or you're going to find the cost for 9. So how are we going to find that? So for that, the cost of 9 is actually the distance from 2 to 3, that is 1 to 4 to 2 to 3. So let's see how to work on 2 to 3. So for that, second row is infinity and third column would be infinity, referring to the reduced cost matrix of 6, 6th node. Okay, so so what is it? So here, what you're going to do here is the second row will be infinity and third column will be infinity. Okay, so copying balance, and also 3, 1, right? 3, 1 you're not going to work. That will be infinity. 3, 1 will be infinity. So here you're going to copy the balanced values. This is all infinity, and the fourth column is infinity. Here it is 2, infinity, infinity. Now when you look, the next step is you have to reduce. So here it's not 0. So take 2 out and 11 out. So our cap is equal to 11 plus 2, which is equal to 13. So now let us see the cost of 9, which is cost from 2 to 3 plus reduce the cost of 6 plus cost of the just now what you reduced. So 2 to 3 cost is 11 plus the previous node, that is 6 nodes cost is 28 plus the reduced node is 13. So when you add, you're going to get, okay, it is 52. Yes, 52. So the cost of this is 52. Now let us move to the next one. Let us try from 2 to 5. 2 to 5. That means second row is infinity and fifth column is infinity. So let us refer to the matrix which is given there. So first, second, third, fourth, fifth, 1, 2, 3, 4, 5. Second row are infinity and fifth column are infinity. Next, 5, 1 is infinity. Just copy it. I'm going to copy it. So this is 0, infinity, 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 0, infinity. Now reduce. There's nothing for you to reduce there. Now you have to find the cost. R dash is equal to 0 because it's reduced. Let us find the cost from 2 to 5. So what is cost from 2 to 5? It's 0 plus 28 plus 0, which is equal to 28. So cost of 10 is 28. Now what is next? Next you have to find which one should I explore. Should I explore 9 or 10? So we're going to compare the cost of these two nodes, that is 10 and 9. From this, which one is minimum? 10. So for sure you are going to pick this node and find which is the next possible, vertices that you have to pick. So when you look at this part, so you've covered 1 to 4, then 4 to 2, then 2 to 5, then what is remaining? 3. So let's number this as 11. So now you have to find the cost of this. So to find the cost of this, you have to go to the reduced matrix of 10. So when you look at the reduced matrix of 10, when you apply the following rules, you will get 28 itself. So the cost of this node is 28. So now when you look, see this, so this is a path 1 to 4, 4 to 2, 2 to 5, 5 to 3 to 1. This will be the path to this, and the cost is 28. So now there's something called upper bound. So initially when you start working on this problem, you are going to set the upper bound as infinity. So now once you reach the leaf node, now you don't have any more level to expand or explore. So now you got this as what? 28. So what you're going to do is this 28 will be updated with upper bound, which is 28. And what you're going to do here is, this is 28, right? So you're going to check whether every node's weight, is there any node which is lesser than 28? So now here it is 35, it's greater, you kill the node. It is 53, you kill it. Here it is 31, kill it. Here 52, kill. All the leaf, 50 kill, 36 kill, because every cost is greater than 28, which means this is your minimum cost tour for a travel salesman problem, to start from 1 and to reach from 1. This is a minimum cost tour for the travel salesperson using branch and bound. So this is the method or how to solve the problem using branch and bound technique. Thank you.